In the last video, we talked about how exercise can induce beneficial adaptations in tendon in terms of laying down new collagen and making the tendon get stronger over time if you program that exercise correctly. In this video, I want to look at maybe the opposite of this. What happens with when you're sedentary or when you're immobilized? What happens to tendon strength? So this is a stress strain curve right here. Percent deformation on this axis, stress on this axis, and we're looking at two groups. So this is a tendon, and you've got that toe region, you've got this linear region like this. So let's say this is control group right here in red, and there's this other group that says suspended. And this comes from a study of lab rats, and what the researchers did is they put the lab rats in like a little rat-sized wheelchair, essentially, so they can't use their hind legs, so they just kind of wheel around without putting any load in their hind leg tendons. I think this is a rat Achilles tendon. That's usually what people use. And they did it for, I think, 8 weeks, 12 weeks, some reasonably long amount of time. And you'll notice a few things that are quite different about these two groups of tendons, right? So number one, the control tendon is much stronger, meaning it gets up to it can handle much more stress for a given amount of strain. And number two, it's also stiffer, meaning its slope, like this slope here, is much bigger than the slope here, right? It's a steeper slope. So this gives some strong evidence that being sedentary, being immobilized, will degrade the strength and the stiffness of your tendon. This also seems to happen with age, and what's very interesting is that if you were to look at the stiffness of a tendon let me maybe draw a schematic of this. Same thing, stress strain diagram. Healthy young adult like this. Healthy young adult after some high intensity training. Maybe like, let's see, maybe like this, a little bit steeper, a little bit stronger. Older adult would look like this, so less stiff. Older adult who exercises, maybe, what's a color I haven't used yet? Older adult who exercises, more like this. So just like with bone, we saw that exercise is an incredibly good way to sustain healthy tissue in your musculoskeletal system. And the converse is also true. If you are sedentary or if you are immobilized, for example, in a wheelchair, or for example, during spaceflight, you will suffer degradation in the quality of your tendons. So I want to conclude this little segment with some scientifically based recommendations for what types of exercise are good for being up here versus not here. So according to research, important things: high intensity, meaning running instead of walking, jumping instead of low-intensity bodyweight squats, so on, fast running, explosive lifting, plyometric training. You want the dosage, let's say as with bone, let's say dose appropriate. Because let's suppose you were a personal trainer working with an older client who's been sedentary. Their tendon probably looks like this in terms of its stress strain properties. So you shouldn't give them a training program that would be more appropriate for somebody with a very strong tendon, right? You got to start out in a controlled manner. And as we saw with this, where did it go? This figure. You want a reasonably high number of loading cycles. So you want in a training session, you want maybe 100 to 1,000 tendon loading cycles. So some quick math that might help you if you're doing if you're doing high intensity types of exercise, if you're running fast, you might take 180 to 200 steps per minute. Of course, you have to divide by 2 because that's each leg. But oops, there we go. Steps per minute. So maybe you do some kind of high intensity sprinting protocol. You might want to total probably 5 minutes total, 200 times 5. Although maybe multiply that by 2 because 2 legs. Cycling, I think you end up with very, very roughly on the same order of cadence, maybe like 90 like revolutions, so 180 like half revolutions per minute. Plyometrics programs, from what I remember working with runners, I think we would shoot for like 250-ish, maybe 500 for an advanced athlete loading cycles. So you can do some quick math here. Now, you don't need to be counting every single rep and every single jump and every single step, but using some rough back-of-the-envelope math to try to get to the right amount of tendon loading can be helpful for trying to optimize, say, somebody who's down here who you maybe want them to have a healthier, stronger tendon. And of course, the opposite is also true for people who are injured, people who are coming back from Achilles tendonitis, Achilles tendon rupture. Of course, you need to be much lower and much more gradual in your return to training. But of course, I think you knew that going in.